Okay, good. So, I want you to have an overall understanding, grasp of what we are talking about here. And that will take me back to this particular slide that I shared with you. And I told you then that you should know this slide as the palm, the line on the palm of your hand. I enumerated it as 6 steps, 6 steps, 6 steps in hypothesis testing. I've told you what statistics is all about. Statistics is all about 2 things: the descriptive aspect and the inferential aspect. Description is when you gather data and you present the data the way you have seen it, maybe in tables, frequency, distribution, and all that. You calculate the mean, median, mode. The one you cannot calculate, you present it in bar chart, pie charts. That is statistics. That's the descriptive aspect of statistics. The other aspect of statistics, which is the inferential statistics, is more of trying to compare the data you have found, analyze the data you have found, and make a sense of how of that data as it affects the entire population. As it affects the entire population. That is what inferential statistics is all about. And please take note, these steps I put on the slide, they are like a summary of the entire concept about inferential statistics. All what you do about inferential statistics is just accomplishing these 6 steps. That is inferential statistics. Accomplish these 6 steps is all we do in inferential statistics. In other words, you came up with hypotheses, some claims, and then you want to establish if your claim is valid or not. Okay? So this is essentially what we do in inferential statistics. I want you to view these 6 steps as a kind of the plan of a structure or a building. You want to build a house. You don't just begin to put stones on top of one another or start packing sand. The starting point is to come up with a plan. I want to build a house. Okay, let me come up with a plan. Now, you agree with me that after you have drawn your plan, how you want the house to look like, the shape of the house, the distance of the house to the roads, the block, the different shapes of the room, and all that. You hand over that plan to the site engineer. And when the bricklayers are on the farm and start working, from time to time, you refer back to the plan of the house to be sure you are working according to the book. You are working accordingly. You want to be sure that you are still working according to the guide. So the plan is like a guide on what you are supposed to do, on what you are supposed to construct. So when you look at these steps, these are the various steps in accomplishing inferential statistics. And each step is a whole lot of topic on its own. I told you that again and again. Stating the hypothesis, how you craft the hypothesis, how you write it in mathematical expression. It's a whole lot of topic on its own that you have to study and understand the context. But of course, in an exam, it's just going to be a question, and you will write all these things as summary. But we have to take each of the steps as a topic to discuss them for effectiveness. Now, the next thing is to determine the alpha level. This alpha level is the the minimum error you want to work with, the minimum mistake that you believe is tolerable in your work. The alpha level is the complement of your confidence interval. If I'm working with 95% confidence interval, in other words, this work, I want to be 95% sure that I'm doing the right thing. Or the result I'm going to get must be within the 95% limit. The alpha level will be 5%, and 5% is 0.05. So if I'm to work with a confidence interval of 68%, it means my alpha level will be 32, and that is 0.32. But conventionally, I told you that people work with a confidence interval of 95%, and that makes the alpha level 0.05. In other words, you are saying that the error tolerable in this research should be less than 5%. Now, the next step is to locate the critical point. It means you must draw the goalpost. You must draw the goalpost. It's okay. If you look at this slide, let me illustrate it on this. Let me try to illustrate. Now, if you care to see, I hope you can see my drawing. This is the same way you draw it in your paper. Or to draw. You can't see it.
No, sir.
You can't see my drawing.
No, sir.
Is there anybody that can see it? Can anyone see it?
Nobody's seeing it, sir.
You said?
Nobody is seeing it, sir.
Okay, don't worry. I'll do a screen graph. I'll do a screen graph. Let me finish illustrating it, then I'll do a screen graph. Critical value. Okay, let me use probably let me use my system wants to be hanging again. Just a minute. Okay. Okay. Let me use the whiteboard to illustrate what I'm saying. I hope you can see my whiteboard. I'm leaving the whiteboard now. Can you all see my whiteboard?
Not yet, sir. It's loading.
Okay, it's loading. Okay. Can you see the whiteboard? Can you all see the whiteboard?
Yes. I can see, sir.
Okay. So what I'm saying in essence is that if you draw your curve this way, Can you all see the curve? Can you all see the curve?
Yes, sir. Yes, sir.
Aha. So we are saying that your 65%, your 95% confidence interval, this is what it means. From here to here is 95. And I told you that your alpha level is a complement of that particular this is 95%. Now, your alpha level is a complement of your confidence interval. Can you still see my board? Can you see what I've written?
Yes, sir. 95%, 0.0.
It's not 0.0, it's 0.01.
It's still loading.
Okay. Okay, this place should be. What can you see on the slide? What can you see? Hello?
Is it for that stuff?
What can you see on the whiteboard?
I'm seeing a goalpost.
You can see what?
A goalpost.
What else can you see? Can you see what I'm writing there?
Yes, sir.
Okay. So what we are saying is that when you have 95% confidence interval, the critical value we are talking about is the value of our C at this particular pole, this particular point that we have indicated. So the critical value here is our Z value. In other words, if you go to your normal distribution table, the value that correspond to this particular percentage, you know, I taught you how to check up percentage in your normal distribution table. So the value of your Z that correspond to this is your critical value. Okay? And what is that critical value for 95% confidence interval? The value is 1.9, 1.96. I hope that is clear.
Yes,
Okay?
sir.
So what we are saying in essence is that this is the goalpost we have set. And after setting this goalpost, we are simply saying that this particular region, becomes our rejection zone. I call it critical region or rejection zone. I hope you remember now. That's our rejection zone. In other words, when we perform our statistics, rejection zone. When we perform our statistics, if our statistics, the value of our statistics, if it falls between this particular inside area, are you getting it? We are going to retain our H0. But if the value of our test statistics falls within this particular rejection zone, we are going to reject our H0, which is the null hypothesis. In other words, this particular value, this critical value, where did we get it? Can somebody remind us? Where did we get this critical value?
T-test table.
From the table. We used to call it the T-tab. We call it T-tab. I'm still going to come back to that. T-tab or T-critical. T-tab. T like this. Then you write tab. I hope you have notes. You people are jotting a few things down. T-tab. So that is our T-tab. Now, by the time we conduct our test statistics, we are going to get a value for our T. By the time we do all our computation, calculation, we are going to get a value for our T. That value of our T is referred to as the T statistics. Sometimes we call it T statistics. That is T stats. Sometimes we call it T computed T. T stats or T computed or T cal. These are the different names you call it. You can call it T cal. Some people will call it T cal. That's the calculated T. T cal. Or you call it T stat. Or you can call it T computed. So you call it T com. That's the value for our computed T when we calculate. While this one we got from the table is sometimes referred to as our T tab or critical value. Those are the two information. I want you to bear these things in mind because we are going to refer to them at some point in the course of this course. And you must know what they are, otherwise you are out. Can you all hear me? Hello, are we together?
Yes, sir.
My system is misbehaving. Any questions so far?
Okay, sir. The T tab or T critical, What's the difference between it and the other ones you made mention of? That is the T values.
That's like what I just explained. I said one, you got it from the table. One, you calculated it.
Okay.
Because you are going to be given values, you are going to calculate. So what you are calculating is your T count. That is the T statistic itself. You understand?
Okay.
So
Yes,
when
sir.
you do that calculation, it's going to be the most part of what we're going to do here. I've just explained to you the T tab. The T tab is what you got from the table. Now, please take
Okay.
note of this. Very, very important. Very, very important. For you to know, for the Z test we have been discussing so far, are you getting it? The Z test, that's the normal distribution test before we enter into T test. For the Z test, all you need to know to go to your table and search is just your confidence interval or your alpha level. It is your alpha level, you just go to your table and check, and it is presumed the alpha level is uniform for your normal distribution table. But there's something that's going to change when we are dealing with our T table. I will explain that in a moment. My system is still rolling. Any other question, please? Question? Is Debbie there? Debbie, is Debbie there? Hello? Is Debbie on the, is she on the platform? Hello? Can you hear me? Can anybody hear me?
Yes, sir.
Yes, I can hear you.
Is Debbie on the platform?
No, she's
No,
not.
sir.
I just started the.
Please mute yourself. Some of you are disturbing. Is Frank on the platform? Frank?
Yes, sir. I'm here, sir.
Okay, good. How about Chisom? Chisom, is Chisom there? How about Emmanuel? Is Emmanuel here? Hello?
Hello, sir.
Is Emmanuel on the thread?
Not actually, sir. I've not seen him.
My system is seriously hanging. So what I'll do is that I'll restart the system, then we'll continue. Please just give me a minute. The system is seriously, I can't even do any other thing.